Right. Physics. 1718 version 1. Okay, let's go section B. Okay. Well. Look what the cat dragged in. What delayed you? Now, if you're going to say the bus, you're getting a slap. Don't tell me the bus was late again.
Too late.
What?
Too late.
Okay, that's a more honest answer now. Right. A small lead weight of mass 250 grams is attached to one end of a piece of string of negligible mass. The other end of the string is attached to a fixed support, and the lead weight follows a horizontal circular path. So it's like this on an ice. Okay, fine. Right. So I need to give a rough drawing of what's happening here. Oh, my pen is doing that thing again. How do I get out of this mode? I forget what I press a button. Which button now? Whoa, yeah. Come on. No. Oh. It's gotta be one of these. Oh. P for pen. Makes sense. I need to remember that for next time. Okay, so what you have is you have this icy surface, and you have this weight spinning around, like on the tabletop like this. Yep. And let's see, the radius is 0.95. The mass is 0.25. 18 revolutions in 10 seconds means in 1 second it does 1.8 revolution. So the frequency is 1.8 hertz. Oh, well, the first one is not a calculation. A part 1. Anybody? Explain why the lead weight moving at constant speed is still said to be accelerating. Yeah, but why do we say it's accelerating? If it's moving at constant speed, why are we saying it's accelerating?
Because it's actually like that, so not in the motion.
Nearly. This is a classic physics question.
It's not in that straightforward.
Yeah, but so what? Why do we still say it's acceleration?
Because it changes direction.
That's it. Acceleration is the rate of change of velocity. And velocity is speed plus direction. Right? Therefore, a delta in direction, that means a change, implies acceleration. Fair enough? Yeah, okay, we should write that down as our first part. Part 2 in a moment. Okay, you got that? Next part? Yeah? The angular velocity, that's the omega. Omega equals 2 pi over t, which equals 2 pi over, and t is 1 over f. So it's equal to 2 pi f. So that's equal to 6.283 times 1.8. So what is that, please? Give me 4 SF. 11.31. Okay. Which is roughly 11.3 radians per second. Okay, what's next? Part 3, what's the tension? So tension equals the force, which equals MA, which equals M omega squared or, because the A is omega squared or, isn't it? Which is 0.25 times 11.31 squared times 0.95. 4 significant figures again, please.
30.38.
Which is roughly 30.4 newtons. Okay, you should write that down. That's part A done. 6 marks. Okie dokie. Got that? Yeah? Okay. B part? Yeah. One end of a length of string is attached to a support so that it hangs vertically downwards. So basically all they've done is they've put it vertical now, and they pull it 45 millimeters from equilibrium and release, so it vibrates a simple harmonic motion. But it's a simple pendulum. Okay, so the picture now is like this, and it's going to be moving back and forth like that. And the length is 0.95 meters. The mass is still your 0.25 kilograms. Yeah. And the amplitude is 45 millimeters. And the question is, define simple harmonic motion. Define simple harmonic motion. Right. Simple harmonic motion is motion why do I want to put the grammar? Subject to a force which is proportional to displacement from equilibrium and acting opposite to the direction displaced. I.e., do you know what? Sorry, I just going to change one word here. Not that it matters too much, but make that force and acceleration. Oh, this better be the bank. 1 second. Hello? It is, yes. Grand, thanks for calling back. That's it on Friday, about 11:45. No, now I don't have the receipt on me, it's at home. But I mean, if you needed the number from it or something, I can get it for you after lunch. Sure. Yep, grand, okay. Grand. Yes. Grand, okay, thanks for that. So, yeah, I was a bit surprised that I didn't see it. Yeah, and I definitely have the receipt for it as well. So, yeah, okay, grand. All right, thanks. 20.99, 20.19 hertz, which is 20.2 hertz. Okay. Right, that was fine. Next one, what is the magnitude of the acceleration when it's 30 millimeters from equilibrium? So, which acceleration formula is that? That is a squared. Now, it's magnitude, so we don't care about the sign. Omega squared x, isn't it? No, sorry. It's a is omega squared x. So that will be 20.19 squared times 30 millimeters, which is 3 centimeters.
For part 2, why is it 20.2?
Well, that's what you told me.
Yeah, but like, if I make t first and then reverse it, then I get 0.511 instead of, did you get 0.5?
You saying this answer's not right?
No, because I did t and then 1 over t.
Yeah, it should be. Sorry, that's my fault. Here, it's probably wrong because you probably typed it in as 2 pi on the top. It should be 1 over 2 pi. Thank you. So, what did you get, Dorian?
0.511.
0.519?
11.
0.511
Yes.
after the 1?
0. Oh shit.
Okay, so 0.511. So we just change that to 0.511, and what do we get? No, we don't change that, Stephen. Change that one to 0.511. What do we get? I'm distracted because the bank stole my money. That's.
What did they say?
They said, "Oh, we'll check that and call you back." I'm like, yeah. It's very strange. I'm like, yeah, no, I know it is. Where's my money, man? What'd you get?
7.85 times 10 to the minus 3.
Okay. Yeah. What is the kinetic energy? Whoa. Oh, dudes. Okay. What is the kinetic energy? Okay. Kinetic energy is a half v squared. The only problem is we don't know the v squared, but we have a formula for v squared, don't we? It's a squared.
B squared minus.
Isn't there a formula that says v squared equals a squared omega squared minus? No. Yeah.
Plus minus omega.
If you square everything, it's like this, is it? Is that right? That's one of the formulas, isn't it? No, something feels wrong with that. Sorry, it's omega squared a squared minus x squared. Yeah, isn't that a formula? Simple harmonic motion formula. V equals plus or minus omega root a squared minus x squared.
Oh, yeah,
It is one. Yeah, you can confirm that, Diego.
V equals plus minus omega.
Yeah. Great. Okay. So then this is omega squared a squared minus x squared. Yeah. So that's 0.25 over 2. What did we say the omega was earlier? Did we get the omega earlier? Did we? We never actually got the omega earlier. Well, it'll be 2 pi f. The amplitude is 0.045 squared minus 0.025 squared. Okay, so what did we say the frequency was? Oh, well, these cancel. What did we say the frequency was? 0.5114. Okay. Five point
62 times 10 to the minus 4.
joules. It's okay. Okay. Yeah, is that okay? 5. Determine the potential energy. Oh, okay, fine. Potential energy.
1/2.
What way do I want to do this one?
1/2 and a half thing omega squared s x squared.
Oh, yeah, I forgot.
Half
Oh,
thing omega squared x squared.
oh. That's interesting. That's interesting. I wonder, will that give me the same answer as this? Exciting.
And how do you know the h?
We'll work it out by trigonometry. Because you have the displacement from the origin and the radius. You could work it out. Ooh, okay. Okay. A half omega squared x squared, isn't it?
Yeah.
Oh, should have worked out the omega. It's 2 pi f. Well, the 2's cancel again.
2 times 0.5114.
Yeah. Oh, wait, no, hang on. That omega is squared. So there's still a 2, and this pi is squared, and the number is squared, and the x is squared. So it's going to be 0.5 times pi squared times 0.5114 squared 0.025 squared. Yeah. Okay. Say again? 8.07?
8.07? Yeah, 6.
Okay. Oh, that's important. Millijoules. Believable.
Milli is minus 4. It's minus 3.
Oh, it's a minus 3, is it?
It's minus 4.
Okay. Got that? Yeah. Okay, next part. Question 2. So let me see. Right.
So the last one is 25 millimeter.
Okay. Number 2. What is EMF? So EMF is the voltage / potential difference provided by a source in a circuit, typically 2 Alton typically, or 1? 2. Typically by a cell or battery. That should get me my 2 marks, I hope. So you notice that my definition isn't word for word matching what I gave you. For example, in my definition, I think rather than using the word source, I would have used the word seat. Not that it matters. Rather than using provided, I think maybe the definition used developed or supplied. But you get the idea. It doesn't matter. You know, it's not a word for word thing we're looking for here. You know. Okay, continue. Continue.
Yeah.
Yes. So what have we got going on here? We have a little circuit, internal resistance, the usual story here. No, this is a, we have to complete the table. So how do we get the V?
I times R.
Yeah. Ooh, let me try print screen here, and then I wonder can I paste it here? Oh no, that didn't quite work. The plan. Hang on, let me try again. Print screen. Whole screen. Close. Paste. Paste. No. Hang on. Okay. Print screen. Whole screen. Okay. No, leave me. Oh, this is.
Copy to clipboard.
Where's copy to clipboard?
Edit. Down.
Exciting. No.
Copy
Come on.
paste the document. Is everything fine?
Why the heck does this program not have a paste function? Okay.
Where did it go?
You saw it?
I think I did. View.
No. I think you just imagined it.
It's
Maybe it's in Scratchpad.
Undo paste thing. So there is a paste. Oh well.
Copy to clipboard. Paste from clipboard. But it's upside down.
Can you rotate the home?
Yes, I can actually. Whoa! A success. Okay. So now we can write on this.
But now you have to go up instead of down. Just
No, don't worry. You have your VI-OR triangle. So V is I times OR. So yeah, if we multiply these two, let's write the number in.
1.438.
1.438.
Next is 1.488.
Okay.
Next 1.506.
1.506.
Next is 1.512.
1.512 and
Next one is
1.52.
1.52.
So we've done the first part here. Use the graph, plot voltage against current. Nice. So let's see if I can squish it in here. Now this is obviously, don't do this in the exam. Voltage, current in amps, and it looks like these values are kind of close together. So, you know, there'd be like 1.4 here, and then maybe 1.5 here, and the, oh no, sorry, I have the wrong way. Sorry. This side is voltage, and this side is current, and current goes up to,
0.15.
yeah,
No.
no, it goes up to,
0.75.
yeah, so I'll just say 1 amp is here. There's half an amp, quarter, 3/4, and the voltage goes up to, let's say here is 1.5. So the first value, for example, is 0.719 and 1.43. So, you know, it'd be like there. And the smallest value would be, for example, 0.152 and oh yeah, I made a real big dinner of this. Now obviously in the exam do it properly, okay? I'm saving time by just giving you a rough idea of what you do.
So we don't have to like switch. Oh no.
It's okay?
Yeah.
Right, so in the exam when you have your graph paper, you are supposed to draw a big triangle here and calculate the slope. So you'd calculate this distance over this distance. So the slope, that would be here 1.438
Integrate.
minus 1.52 over, no, yes, over 0.719 minus 0.152. Negative?
Syntax error how? Negative 1.0144. No, 0.144, sorry.
0.144. Okay, well anyways, roughly, 1.145.
Negative, yeah.
One
It's negative 0.144, no 1.
negative 0.1.
0.14466.
Okay, so that's minus 0.145, and the unit is,
One of
no, ohms actually for this one. No,
it's voltage over current, so
yeah, it's the correct
Okay.
unit. Yeah. What's next? You get the EMF and the internal resistance. Okay, so the EMF, the internal resistance first, that's easy. That's 0.145 ohms. Yeah? And the internal the EMF is what on the graph? No, not this one.
it's the y-intercept.
It's the y-intercept, which is here. Okay? Yes? Now, this is where you need graph paper. What the heck is it? I would say it's, I don't know, maybe about 1.6. I'm just going to write 1.6 down. Obviously use graph paper in the exam. Do it properly. Yeah? Okay. Next now. Ah, nice. The Kirchhoff one. Okay. Can we do the Kirchhoff one?
Yeah.
Oh, let me try my print screen again. Print screen. Let's just try current window. No. No, stop. How did I do this last time? Copy to clipboard. Ah.
I think you click paste from clipboard.
Oh yeah, for some reason that did it. Not this time. Copy,
And then paste.
paste,
Yeah.
and then
How did you click paste in that with the paste?
I don't know.
Paint it.
What's save, copy, paste, copy, paste, paste, paste. Alright, fine. Not this time. Not this time. Okay, let's just switch between the two. Right, where will we start? Where will we start?
2 volts going
2 going around? Okay, so that's 2 minus 5i1 minus 6i3 plus 3 equals 0. So that is 5i1 plus 6i3 equals 5.
I3.
Thank you. Equals 5. Equation 1. Equation 2 should be a junction. Let's see. I3 goes in. I1 comes out. and then I2 is going in, so that's a plus I2 equals 0, or in other words, I1 minus I2 minus I3 equals 0. That's equation 2. And lastly, let's loop around the right. Yeah? 4
minus 3.
Yeah, 4 minus 3. Now what's happening here? The current is going up, but we're going backwards through it, aren't we?
So it's plus.
So it's plus 6I3. Yeah? Minus 8I2 equals 0. So 6I3 minus 8I2, or maybe I'll say 8I2 minus 6I3 equals 1. Okay, what can we cancel from everything that's in everything? I3.
Yes.
Because look what we can do. We can put a 6, and a 6 here. Yeah? And then we could make this negative, positive, positive, negative, positive, negative. And then we'll just combine these two. 5I1 minus 6I1 is 11I1. Minus 6I2 equals 5. And then we put these together. Minus 6I1 plus 8I2. They cancel, equals 1. Okay. Now, how to put these together? Yeah, plus 1, isn't it? Okay, yeah. Could multiply this by 8 and this by 6. So what will we get? We'd get 88I1, yes? Minus 48, isn't it? Oh, the smallest numbers, isn't there? Times 4 times 3, because they'd be about 24 then, thank you. 44I1 minus 24I2 equals 20. And then plus, and then if you add them, yeah, what's that, 26 is it? 26I1 equals 23. Okay, so we're done practically now. I1 is 23 over 26, so what's that?
0.885
amps. I2 we can get by subbing that in here. So you can say or even maybe this one looks a little easier. 11 times 0.885 minus 5 over 6. That'll give me the I2. What's that? And then finally, I3 I can get from here. I can say I3 is I2, I1 minus I2. So this number minus this number gives me I3. So what's that? 0.097 amps then. Okay, so that's the Kirchhoff question then. So we'll write that down, and then I think that finishes off this question nicely. So then next time we have a look at the materials question. Okay, so just...
the section B, we only choose 2 in the exam.
I think so, yeah.
Oh.
I only marked the first 2 in order that you did them. I know. Anyways, just pick what 2 look better, or in other words, don't do the hardest looking one.
repeat all of the examiner and just pick a highest mark and marks.
You can't do that because you only marks the first
I know.
two.
No, I know, but well, not most, but in some schools, if you do more, they mark the best ones.
And you keep the best.
Yeah. How was that? How were those two questions?
Alright.
Were they? So- Yeah. When's our next physics this week? Oh, is it? Morning class?
We have a double tomorrow.
Double 9 o'clock? Or 11?
We'll
No,
see you
it's
at
before
12 to
and
1
after.
and then 2
Oh.
to 3.
Oh, yeah, split.
Yeah.
Yeah.
So you, then lunch, then you, then
What do we have at first?
double maths.
I think I'll need to have a shawarma between those two classes.
Chemistry, no, we have everything.
Yeah.
Thanks for helping on Friday. A lot of the students did a terrible job because I spent about an hour afterwards deleting all the questions people uploaded wrongly.
Did you see something special?
I did see something special, yes. That's something I had to delete too.
I would just like draw a picture and just put like
Credits, please. Yeah.
credits. Yeah.
Trust me, you don't want your credits assigned to that, not until I clean it up. Anyways, what class you got next? Are you in here or what?
Yeah, we can.
Yeah. So we'll continue with this exam tomorrow, and then what I was thinking is,
Is this our
Yeah.
last week or second last?
No,
Second
second
last.
last.
We finished the 20.
Before term 1, yeah.
Whoa.
Oh.
yeah.
I have a question.
Yeah.
Why sometimes the cells are written like a long one, a long thing, and a small one, and other times it's a long one and kind of like a square?
Huh? What are we talking about?